It's been a long time since pilots would begin a commercial airliner flight by jumping in the cockpit, shouting contact, and having someone spin the prop. When preparing for a safe and efficient flight, dispatchers and pilots must consider many factors, including wind speed and direction, ambient temperature, the airplane's takeoff weight and center of gravity, or CG. Weight is important for determining required takeoff and landing field lengths, available climb and obstacle clearing capability, the allowable amount of reduced takeoff thrust to extend engine life, proper takeoff and landing speeds, accurate fuel planning, and compliance with weight and payload loading limitations. In addition to weight, balance, or more specifically CG, is important for ensuring compliance with CG and payload distribution limitations, acceptable airplane handling qualities, and proper takeoff stabilizer trim settings. Actual airplane weight during operations is the weight of items such as fuel, crew, catering, passengers, baggage, and cargo added to the basic empty weight. And airplane CG during operations is the result of the distribution of that additional weight on the basic empty weight CG. This program will show the Boeing recommended procedure for weighing an airplane to obtain accurate basic empty weight and basic empty weight CG. We'll begin with an introduction to help us understand the terminology and basic concepts of weight and balance. Then we'll see preparations for weighing, including servicing of related systems, conducting an airplane inventory, moving the airplane to an appropriate location, and setting the airplane configuration. Next, we'll show the weighing process using platform scales. And finally, we'll see the analytical adjustments you apply to determine the basic empty weight and the basic empty weight center of gravity. Keep in mind, this program is for training purposes only. For current and complete information, always see the appropriate airplane maintenance manual, weight and balance manual, any applicable regulations, and your own company's procedures. Also, although this program will show weighing a 737-700, the same general procedure is valid for all models. Major exceptions will be noted where appropriate. The process we are going to learn is deceptively simple in that putting the airplane on a set of scales and adding their readings will tell you what the airplane weighs. But getting accurate and reliable readings and determining accurate CG involves strict adherence to a consistent, reliable, and detailed process. In order to fully understand this, we need to understand some basic concepts and the terminology we will use. The first term is the most obvious: scale weight. You obtain the scale weight by placing the airplane on a number of scales and adding the readings from each of those scales. Basic empty weight, or BEW, is the weight of the airplane in its baseline configuration. That baseline configuration is defined differently from airline to airline, but can be characterized as the weight of the empty airplane, not including those items that are likely to be different from flight to flight. The center of gravity, or CG, of any object can be defined as that point around which all of the weight of that object is evenly distributed, or all of the forces of gravity are in balance. The location of an airplane CG affects how the airplane responds to control inputs, how it flies, and how the load in the airplane is carried by the airplane structure. The basic empty weight CG is the CG of the airplane when it is in its basic empty configuration, that is, minus those items that are likely to change from flight to flight. We should also point out that we are only concerned with longitudinal CG, the center of gravity fore and aft. The longitudinal location, or balance arm, of the CG is measured in inches after the reference datum. This datum is defined by Boeing and is different for each airplane model. It can be found in your airplane's weight and balance, control and loading manual. Similarly, the longitudinal location of all airplane component centers of gravity are referred to as the component's balance arm. Now that we know about the datum and balance arms, we're ready to discuss how to determine CG from the scale readings. To begin, you will need to know the reading from each scale. You use a different number of scales depending on the model of airplane you are weighing. For the 737, we use one scale under the nose gear and one scale under each of the main gear wheels for a total of 5. We'll see all the scales later on, but for the sake of this discussion, we'll consider all the main gear scales as one. You will also need to know the balance arm for the point contact between each scale and its landing gear wheel. You then multiply the reading at each scale by the balance arm for that scale, add the result together, and then divide that sum by the total weight. Now let's look at preparing the airplane to be weighed. Many discrepancies in aircraft weighing are the result of improper preparation, so this is an extremely important part of the process. Keep in mind, we're just going to summarize these items, so be sure to see Chapter 12 of the Airplane Maintenance Manual for specific servicing instructions. We'll begin with defueling. Remove as much fuel as possible by pumping out to a fuel truck. Now, make sure the airplane is level to the specifications for defueling provided in the maintenance manual. Note that the airplane pitch attitude for defueling may not be 0 degrees. Then attach fuel drains to the sump drain fittings. Allow the fuel to drain until there is less than 1 drip per second. Next, drain the potable water system. Remember to open the valves in the lavatories to allow the water in the lines to drain completely. Now drain the waste tanks. Next, service the following system fluids for flight: the hydraulic systems, the engine oil systems, the APU oil, and the landing gear fluids. Also, check to ensure all oxygen bottles are serviced for flight. Note, if you cannot service any of these systems for flight, you must analytically account for the weight and CG effects produced by any missing fluids. Next, we need to conduct an airplane inventory. Experience has shown us that problems with getting an accurate basic empty weight often come from errors in this part of the process. So let's take a moment to understand why an accurate inventory is important. As mentioned earlier, in order to predict an airplane's actual weight during operation, you must start with the airplane's basic empty weight. But how do you know what is and what is not included in the BEW? That's where the inventory list comes in. An inventory list must be created that completely defines the contents of the airplane in its BEW configuration. One of the many documents that are delivered with a new airplane from Boeing is the Weight and Balance Manual. Chapter 2 of that manual includes an inventory list that documents the empty weight configuration of an airplane at delivery. Airlines should use this as the starting point for creating their own list that documents their own definition of the airplane's BEW contents. Prior to any weighing, an inventory of the airplane must be done. Our goal is to conform the airplane's contents as closely as possible to the BEW configuration defined by the inventory list. This means removing any items that are not supposed to be on the airplane according to the list, replacing any items that are missing according to the list, and documenting any differences that can't be corrected. Begin the inventory by checking the cargo compartments. Here's an example of something that needs to be removed. Next, check E&E bays. Here's an example of something that's missing. Normally, we would replace a missing item, but this component is out for service and will not be returned prior to weighing, so we need to document its weight and normal location. Next, check the main cabin. Make sure all waste containers are empty, as well as galley carts, ovens, and refrigerators. Also, make sure the stowage bins are empty except for emergency equipment. Here's an example of something that's missing that we can replace. And check literature pockets and racks. Finally, check the flight deck. Our goal is to put the airplane in the predefined BEW configuration as closely as possible. This will minimize analytical adjustments that will need to later be applied to the scale weight to calculate the BEW. Now let's look at the location of the airplane during weighing. FAA Advisory Circular 120-27D advises that you should weigh airplanes in an enclosed building because scale readings stabilize faster in the absence of drafts from open doors. And that's the way Boeing does it for all 737, 747, 757, 767, and 777 airplanes. The building should be large enough so you can completely close the doors with the airplane and tow vehicle inside. And you should control the ventilation system so there is no air movement. In addition, the floor should be level. Note that Boeing has no technical objection to weighing airplanes outside, as long as the wind velocity at the times the weights are recorded is within the limits considered acceptable to your regulatory authority. In all weighings, the airplane exterior should be clean and dry. Obviously, any water on the airplane will make the airplane heavier and may affect the airplane CG. Set the leading and trailing edge flaps and slats to be either fully retracted or fully extended. Boeing recommends weighing with flaps and slats fully retracted to eliminate the possibility of damage during the weighing process. Set the horizontal stabilizer to its neutral position. Close all passenger and cargo doors and move all seat backs to their upright positions. Remove any exterior lines attached to the airplane. Finally, check that the airplane is level. You won't need to level the airplane exactly until after it is moved onto the scales, but you want to get it close now because major attitude adjustments with the airplane on the scales can cause side loads that can lead to inaccurate readings. Note that a plumb bob is not included with the airplane, nor in the BEW. You will need to supply your own. Make sure to remove it when the weighing is complete. And although it is not required, for best results, we recommend also leveling the airplane laterally. With the airplane preparations complete, we are ready to begin weighing. We'll be using platform scales since they are the most common. There are several manufacturers of platform scales. Make sure the ones you use are certified to meet or exceed the requirements of your regulatory agency. Both the Boeing Company and Joint Airworthiness Regulations, or JAROPS, recommend an accuracy of 0.1%. And only use scales whose calibration certification is current. Set up the ramps, scales, and spacers according to the manufacturer's instructions. On the 737, you will need one set for the nose gear and one for each of the main gear wheels. Before taking any readings, you should exercise the scales by temporarily towing the airplane onto the scales. This is to make sure the platforms are operating freely and giving accurate readings. If at this point or at any point in the process, a scale shows readings that you suspect are inaccurate, investigate and take corrective action. This could mean replacing a defective or out of calibration scale. When you are sure the scales are operating correctly, tow the airplane off the scales and onto the spacers. Make sure the scales zero according to the scale manufacturer's instructions after the plane has moved onto the spacers. Now tow the airplane back onto the scales. Once the airplane has come to rest on the scales, set the parking brake. Caution: do not use the airplane brakes to stop the airplane on the scales. This could damage the scales or induce side loads on the scales, resulting in erroneous readings. Make sure to close any open windows, move the captain's and first officer's seats fully forward, and close all doors as you leave the airplane. Then disconnect the tow bar. Now make sure the airplane is level to 0 degree fore and aft. Note that even though there is a bubble level on some models, Boeing recommends always using a plumb bob for all leveling activities. If the airplane is not level during weighing, you will get inaccurate readings related to the distribution of weight fore and aft. This will change the distribution of weight on the scales, and that will lead to an erroneous calculation of the center of gravity. Also note that with the 767-400ER, it is not possible to level the airplane to 0 degree. This model always requires a non-level weighing adjustment to be applied to the scale-calculated CG. Next, measure and record the oleo extensions for landing gear with non-vertical struts. On this airplane, the 737-700, that means the main gear. You only measure the extension of non-vertical struts because changes in the extension of non-vertical struts will result in changes in the balance arms of the landing gear. You are now ready to record the airplane's weight. It's best if you record all the readings at the same time. This would mean coordinating taking the readings with at least one person at each scale. Note, some scales can connect to a computer, allowing one person to read all the scales at the same time. This method can have the added benefit of allowing software tools to perform and document all required calculations. Now, after releasing the parking brake, move the airplane back onto the spacers. Wait for the scales to re-zero according to the scale manufacturer's instructions. Then move the plane back onto the scales. Set the brakes and evacuate the airplane as before. level the airplane, and measure and record oleo extensions as before, and record the weights a second time. If the total weight of the airplane is within acceptable tolerance with the first reading, record the first readings and you are done with this part of the process. At Boeing, acceptable tolerance for weight means 30 pounds for narrow-body airplanes and 50 pounds for wide-body airplanes. Acceptable tolerance for CG means 0.2 inch in airplane CG. If the second reading is not within tolerance with the first reading, repeat the weighing a third time. If the second and third weights do not agree within tolerance, you must investigate and take corrective action. Errors in repeatability must be the result of either variations in environment, such as having the hangar ventilation system on, variations or errors in process, such as taking the reading before all non-airplane equipment has been removed, or intermittent problems with the weighing equipment. Repeat weighing until two successive weights and CGs do agree within tolerance, and record the first of the two readings. This will be the recorded scale weight and CG that provides the basis of the BEW and BEW CG. To calculate the final BEW and BEW CG, you will need to apply analytical adjustments to the recorded scale weight and CG to account for the effects of removing items that were on the airplane during the weighing but are not included in the BEW, adding items that were not on the airplane during the weighing but are included in the BEW, full extension or retraction of the flaps and slats to their BEW defined positions if these positions are different from what was weighed, adding drainable fuel that is to be included in the BEW, adding any system fluids that were not at their full dispatch-ready levels during the weighing, non-level weighing if the airplane could not be leveled to a zero-pitch attitude, latitude and altitude correction to 1 standard G if necessary. The final step is to carefully document the results. This documentation could be similar to the Boeing-created Weight and Balance Manual Chapter 2 documentation mentioned earlier. Boeing recommends that an airline's documentation include final BEW calculation, airplane configuration summary, location and zone diagram for organizing of the inventory list, aircraft weighing results, aircraft weighing checklist. In conclusion, airplane weight and CG must be accurately known to ensure safety during all operations, both in the air and on the ground. The primary basis of an airplane's weight and CG at any point during its operation is a complete and accurate weighing as described in this video.